Are those children in the lab coats? I don't know. What are they gonna do?
No, what are they gonna do?
They're gonna freeze stuff on. I don't know. What are they gonna freeze them on? No.
What's that?
They're gonna do science experiments.
On the shirt, is it able to go in the washing machine?
No. Yeah, you don't want to.
So how can you take all the
Well, you could put it in on. Lily, look, the crystal on the wall looks like Elsa. See? Look right there. It looks like Elsa's crystal. You see it on the wall? Chinese crystal, right there. On the wall. Look up there.
喺邊度嚟嘅呢度？
咪就係呢度。
就喺呢度嚟。我以前係啲戰爭嘅 K.O. 嚟。
Oh, yeah, I was listening. My grandfather came Grandma's ass. What do you do?
Sweeping.
Yeah. I asked Lily for her grandma. She said, "At grandma." And I said, what do you think you're doing? You're both of them. No, both of them went to sleep. Oh, it's very funny. The post office was in a good place. Do you think, no, it's a Sunday. The post office was closed. It is, but only in the morning. They're starting to win 2 minutes. Yeah, you'll see. Oh, until they start? Okay. Yeah, you'll see. This was a great idea to come to. What a fun activity.
佢好特別呢間嘢，成5000幾個冇經
Is that? Oh, you're right. Where is that? Oh, I'm sorry.
No worries.
Let me see. Thank you.
It's a bird. Oh, Lily, watch out for this. That's part of the computer. It's so yeah. Oh. Just watch.
Make sure that make sure that
Pretty funny, actually. Was he a scientist? Yeah. Yeah, interesting. What? Yeah. Oh, I'm sorry. What was it next?
high school is the tradition.
And I said next time, I didn't like that. You gotta sit close to me. Do you want to sit on my lap?
He said he's like,
Okay, sit close to me.
he's not like his son's like,
Look around me. Yeah. I don't know what that helps. Without actually a We were going to come last year. Moonlight to Or is this the first
next see, next year.
Like, the only thing I've ever seen someone take me about anything was grilling vegetables. It was very specific. Yeah, I know. It's insane. Because you've done it in the first type thing is like putting back. Okay, I think it started.
The problems that the nation faces are complex. We need science more than ever. Here at Brookhaven National Laboratory, we are looking into little corners of the universe you can only look into in a facility like this. We have a trailblazing future.
The mystery of matter itself are being taught here at Brookhaven National Laboratory.
5,000 acres, 300 buildings.
About 3,000 people work here at this facility. It's about a $600 million annual budget. We have 3,000 to 4,000 people coming each year to use the facility to be available for free.
The phenomenal scientists that are here enable us to solve problems that otherwise could not be solved.
We're trying to solve why your cell phone battery died after a few years, which is a new drug. All these problems require science, cutting-edge science to answer.
We have scientists here investigating creation of new materials. It sounds like science fiction, but
Our job is to help expand countries' energy options. Plants are the future. We're trying to manipulate plants to make more sustainable energy.
A singular light source is essentially a very large X-ray machine. Used at the scale you fit Yankee Stadium inside this room. We focus the down to about 30 gold and that's a world record with no other working microscope can deliver.
Data-centered computing has really fundamentally scientists produce more data than they can analyze. We develop algorithms and tell them where interesting things are happening. We are helping people to make the discoveries of the future here at Brookhaven National Laboratory.
Alright, welcome everybody. Thank you so much for being here this afternoon. We're about to get started with the 3 p.m. liquid nitrogen show. So just please ask you to silence your electronic devices and find your seats. So before we get started, just a couple quick agenda items. The first thing is your safety is our top priority. So in the event that there is an emergency, please stay calm and follow directions given by laboratory staff. If you hear the building fire alarm, please proceed to the nearest exit. There are exits in the rear of the auditorium, in the front of the auditorium, and at the sides of the auditorium. If you should hear a steady siren, please shelter in place in the indoor assembly area located in the lobby. Walk, don't run, and watch your step. You may notice the lights in this room right now are a little bit dim, so we're just going to ask everybody to remain seated during the show, unless otherwise instructed by me to come up for some volunteer participation. At the end of the show, staff will stamp Explorer guides as you exit. That will be in the rear as you're walking out of the auditorium. You can get those Explorer guides stamped. All right? Awesome. Okay, with all that out of the way, I can properly introduce myself. Greetings, everybody. My name is Jonathan Ullman. I am a senior educator here at Brookhaven National Lab, and I'm really excited to be hosting this show for you guys today. I do want to complain, though. I wasn't really getting the right picture when they first asked me to do this. So the way I heard it, when the lab approached me, they said, "Hey, Jonathan, we want you to host the coolest show on earth." And I thought, me? Cool? But that's not what they said. They said, yeah, we're going to have to ask you to come in on Sunday, and we want you to host the coldest show on earth. So I got my wires crossed there a little bit. But nonetheless, I am still excited to be here with you all, and I'm really excited to introduce our rock star demonstrators today. So, first off, she is a senior piping designer as well as a design engineer for the Electron-Ion Collider. And on weekends, you can find her baking the most delicious cookies this side of the Mississippi. Please put your hands together for Jennifer Maseko. Next, he is a cryogenic engineer as well as a control account manager. And on Thursday evenings, you can find him tracking down fly balls in the outfield during softball. Let's hear it for Chintan Shad. All right. We've got a really great show planned for you guys. We've got some really cool demonstrations. I'm going to be coming around, engaging with the audience, asking you your predictions, your hypotheses, what do you think is going to happen before we do the demonstrations. I've even got some trivia questions and some dad jokes for some downtime periods. So yeah, we'll see how those go. But are you ready to get started? Yeah. Let's do it. We're going to start off with our first demonstration. And for this demonstration, well, I thought it'd be nice to make a hot cup of tea. Okay, so we have our tea kettle, but we actually don't have all the necessary tools in order to make tea like you're familiar with. Right? I don't have a stove top. I don't have a way to boil water. I don't even know if we have water. But we do have liquid nitrogen. So should we try to make some liquid nitrogen tea? What do you all think? Yeah. Let's do it. Okay. So we'll start by pouring some liquid nitrogen into the tea kettle. Now, let's see. What do you think is going to happen when we do this? Any ideas? Get cold, maybe? Maybe freeze the tea kettle? What do you think? Okay, well, right now there's actually no water inside the tea kettle. That would probably happen if there was. That's a great idea. All right, well, as you can see, definitely looks like things are heating up over there. So we're going to go ahead and put the top of our tea kettle on. And do you all hear that? Sounds like our tea is just about ready. So what's going on here? Well, turns out liquid nitrogen is cold. And I mean very, very, very cold. So we actually don't need a stovetop. We don't need a flame to boil liquid nitrogen, because liquid nitrogen will boil away even just in the room's temperature. right? In this mildly air-conditioned auditorium, that's hot enough to cause the liquid nitrogen to boil away into gaseous nitrogen. Okay? Shall we do a trivia question? Yeah? Okay. If you get the trivia question correct, you stand to win one of these sweet maze pens. And I will admit these are kind of tricky questions, but they're multiple choice. So listen closely. First question. At what temperature does liquid nitrogen begin to boil and revert back into a gaseous state? Is it A, 100 degrees Celsius? Is it B, 0 degrees Celsius? Is it C, minus 96 degrees Celsius? Or is it D, minus 196 degrees Celsius? Let's see. I'm going to come around over to this side. I want to see if you have the answer for me. What do you think? D is correct. Minus 196 degrees Celsius. Nice job. I'll be right back with your base then. Hang on. Nice job.
即係佢平時係氣體咁樣。
Okay. I think we're ready for our next demonstration. So, how many of you folks have ever started to do maybe like a home improvement project before? And maybe you needed to, use a hammer to drive some nails into a piece of wood. Has anybody ever had to do that before? Yeah, me too. And I'm very forgetful. So sometimes I'll get to the job and I'll totally forget my hammer. And then I'm like, oh no, what am I supposed to do? Well, if this ever happens to you, we're going to give you a quick tip. And you could actually use something in your lunchbox if you know how to do it. What I'm talking about is a banana, okay? So Chintan's got a room temperature banana there, and we're going to try this first. We're going to see, can we drive a nail into a piece of wood with a banana at room temperature? No, didn't work quite so well. But Jennifer has been submerging a banana for us in liquid nitrogen. And this might work a little bit better.
Yay!
Nicely done. So there you have it. If you ever forget your hammer at home, just bring some liquid nitrogen with you and take the banana from your lunchbox. You'll be all set. Now, why does that happen? Well, it turns out bananas, like most other fruits and vegetables, contain some water inside of them. So when we submerge the banana into the freezing cold temperatures of the liquid nitrogen, that water instantaneously freezes into solid ice, and it becomes pretty hard enough to behave like a hammer because of how cold that liquid nitrogen is. Shall we do another trivia question? All right. Nitrogen is an element on the periodic table of elements. How many protons does a nitrogen atom have in its nucleus? Is it A, 5? Is it B, 7? Is it C, 12? Or is it D, 434? How many protons does a nitrogen atom have in its nucleus? What do we think over here?
7.
Very nice. The answer is indeed 7 protons. Very good. How about a quick joke? Okay. How do cryogenicists, people that work with freezing cold substances. How do cryogenicists like to get around? They ride their icicles. Okay, let's do another demonstration. Next up, we have the rubber bouncy ball demonstration. So, Jennifer and Chintan have some rubber bouncy balls. They are at room temperature right now, and so when we drop them from about chest high, what do we expect is going to happen? They're going to bounce. Awesome. Okay, but if we were to submerge rubber bouncy balls into liquid nitrogen, what do you expect might happen when we drop them this time? Let's get some ideas from people in the room. What do you think might happen now? You think maybe they won't bounce? Okay. What do you think? Oh, maybe they're going to break. Okay, interesting idea. Let's get one more thought over here. What do you think? Maybe they're going to become very hard. I love all these thoughts. Let's give it a try. On the count of 3, everybody. 3, 2, 1. All right. Let's try one more time. 3, 2, 1. Absolutely correct there. Our rubber bouncy balls are not nearly as fun as they once were because they have become so frozen and hard that they are not able to actually bounce off of that surface anymore. Excellent. Trivia time. What percentage of the air that we breathe is made up of nitrogen? Is it A, 78%, B, 21%, C, 1%, or D, 0%? How much of the air that we breathe is made up of nitrogen? Come around over here. A, 78% is correct. Nice job. Okay. For this next demonstration, it is crucial that you remain seated unless I select you. I am going to need some volunteers. Now, if you would like to volunteer, you have the best bet of being chosen if you sit quietly with your hand raised. Okay? Let's see. Let's go with 1, 2. See where you are for it. 3, 4, 5, 6. Good. Yep. 7. 8. 9 and 10. All right. If I selected you, please come up to the front. Do not go closer to the stage than I'm standing. And your task is pretty simple. I'm going to ask you each to blow up a balloon. Okay? The balloon should not be any bigger than the one you see in my hand right now. Does everybody think they can do that? Okay. There are a bunch of different colored balloons. Try to remember which color is yours. Okay? You can start blowing. Yeah, go for it. can tie it. Just make sure it's about the same size as the one that I have. That's good, yep. Yes, I can help tie it if need be.
Wow chứ.
Who else going to tell time? All right. Well, awesome. Yep. All right. Okay, friends. Here's the deal. We're going to gently put our balloons onto the stage, and then we'll take a seat or kneel right in front of the stage. All right? So once you're done putting your balloons on the stage, just kind of come over here and kneel like so. On the stage for me. Awesome. All right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 balloons. Sorry, I should be on the mic. We have 12 balloons. Now, here's the bet that I want to make with you. I bet you that we can squeeze all 12 balloons into that container. That's called a dewar. Do you think we can squeeze all 12 balloons into that dewar? Oh, okay. Does anybody think we can't? Okay, well, very good. Let's try it out. 1, 2, feel free to count with me. 3, 4, 5, 6, 7, 8, 9. Okay, this is getting ridiculous. 10. 11. And 12. All 12 balloons managed to fit inside that tiny container. There you go. Awesome. All right. Well, let's see. I want to challenge you all with another bet. How about this? I bet that I can make it so that all of you that helped blow up the balloons, I'm going to make it so that you all blow up the same balloon with the same breath. that you took? Do you want to take that bet? You stand to win a handful of pennies, if I'm wrong. Yeah? Shall we try it out? Okay. Here comes balloon number 1. And as we can see, it is slowly reinflating with the same breath that you took when you originally blew it up. There's number 2. There's number 3. And they're going to just keep on coming. Let's talk about what we're seeing here, right? Because this is pretty confusing. The balloons, when we inflated them, right, we used our breath. Our breath contains some moisture in the air that we exhale out. And when we place it inside the container with liquid nitrogen, it cools it down so far that it will transition from a gas into a liquid. Then, when we remove the balloon from the doer here, it will warm back up, and the liquefied breath that you took will slowly start to boil away into air again and re-inflate the balloon. So there you have it. I get to keep my pennies. How are we doing? How many balloons are left? All right, here's the deal, friends. I hope you remember which color balloon was yours, because what we'll do once they have re-inflated and then warmed back up to a safe temperature, we will give you your balloon back. You can take it back to your ski bag. All right? So, how about this kind of light blue one? That's yours. Pink. Blue. Okay. Awesome. Once you have your balloon, you can head back to your seat. Orange. There we go. Yellow. Awesome. You're quite welcome. We got a green. Good. We got kind of a teal. We have this teal. Oh, that's not good yours over there, right? We've got kind of a peach. We got purple. Oh, here. I don't know if I'm gonna have enough balloons to give you one. I'm so sorry. Okay, thank you. Red and white. All right. Give it up for the balloons, everybody. All right. That means it's time for liquid nitrogen has a very low viscosity. That means it flows very easily as a liquid. How much more viscous is water compared to liquid nitrogen? Is it A, about 2 times more viscous? Is it B, about 3 times more viscous? Is it C, about 4 times more viscous? Or is it D, about 5 times more viscous? How much more viscous is water compared to liquid nitrogen? Look at it right here. A, about 2 times more viscous is incorrect. Sorry about that. Good try, good try. Let's see. Yes, come back here. What are we thinking?
5.
It is indeed about 5 times more viscous. Nicely done.
Okay.
Another joke I'd be happy to. What is a cryogenicist's favorite healthy lunch option?
Ice cream.
Ice cream.
It's a salad with iceberg lettuce. All right. For our next demonstration, hey, remember all those pennies that I didn't lose in that bet? Let's smash them. So, what we've got is some pennies that we've submerged in liquid nitrogen. This time, we've submerged all of them. Now, Kinsey fished one out. Jennifer is going to take a hammer. And how's our penny doing? It's actually okay, right? Interesting. Let's try again with a different penny. Jason's going to fish one out for us. All right, and Jennifer is going to give it the hammer. What do we think? How's this penny looking? Not so good, right? It's smashed into a bunch of pieces. Let's try it one more time with a third penny. Oh, do we have any more pennies left? Did I run out of money? I probably ran out of money a long time. There you go. Still have one penny left. All right, let's see what it looks like with the hammer. Oh man, that penny smashed into a bunch of little shards, didn't it? Okay, so 2 out of our 3 pennies broke into a million little pieces. 1 penny stayed intact. I'm curious if anybody can think of a reasoning why. Why did only 2 pennies break, but 1 penny stayed the same? Let's see if I can get a microphone down to this young lady. What do you think? Absolutely. So the liquid nitrogen is so cold that some of our pennies do smash into a bunch of pieces, but 1 did not. I think 1 did not. What do you think the difference is? I mean, they're all pennies. What do you think?
The penny that was first was put in the liquid nitrogen first, which makes it more solid.
I really like that idea. The more solid might make it more susceptible to soaring, though, right? So I don't know if that's the answer. Let's get one more thought. What do you think?
Maybe it didn't freeze enough.
It didn't freeze enough. I really like these ideas. Can I explain what's happening here? So, this is a little lesson on economics. Turns out that pennies made before the year 1982 are entirely copper. And copper, when cooled down to a really low temperature, it still retains itself. You can hit it and it will remain intact. However, pennies that were made after the year 1982 are actually more made out of zinc than copper. They're zinc and then coated in a little bit of copper to give it that tin color. And zinc, when you cool zinc down to frigid temperatures, becomes very brittle and easy to break. So, the 2 pennies that we broke must have been more recently made. The penny that stayed intact must have been from before 1982. Pretty cool. Ready for a trivia question? Okay. Which of these celestial objects are suspected to have pockets of subsurface liquid nitrogen buried under a large heart-shaped region of solid nitrogen? Is it A, Mercury? Is it B, the moon? Is it C, Jupiter? Or is it D, Pluto? Which of those celestial objects is thought to maybe have some liquid nitrogen under the surface? What do we think? Mars. What do we think? What do you think? Jupiter? It's a good guess, but unfortunately it's not Jupiter. What do we think? Pluto is correct. Nicely done, my friend. Yeah, Pluto is very far from the sun. It's really cold. Before we do the next demo, have you guys heard the one about the cryogenesis that got hypothermia? No, that one never gets a warm reception. Okay, next demonstration is going to be food related. How many of you guys like to eat cotton candy? Oh yeah, me too. It's one of my favorites when I go to the carnival. So, cotton candy, well, we're going to try two things with cotton candy. The first thing we're going to try is we're going to submerge our cotton candy into liquid water. Does anybody have a hypothesis as to what we should see when we put cotton candy into water? What's going to happen to the cotton candy? I'm coming around. What are we going to see? Very nice. Because it's made of sugar, the cotton candy should dissolve in the water. Let's see if that's true. Let's go ahead and dump that cotton candy right in front of our very eyes. That cotton candy just turned our water into sugar water, right? Okay. Next thing we're going to try is what's going to happen when we submerge cotton candy into liquid nitrogen. Does anybody have any ideas? It's coming up front here. What do you think? Okay, maybe it's going to freeze, right? Because we know it's cold. What do you think? Maybe it's going to become solid, like a rock. I like that idea. Let's get one more idea right here. What do you think, my dear? Okay, maybe it's going to become hard instead of soft. I love these hypotheses. Of course, no wrong answers. Let's give it a try. And when we pull our cotton candy out of the liquid nitrogen, did it dissolve? No. Is it hard? Not really. It's smushy. It's kind of like a sponge to the liquid nitrogen. Were you expecting that? Me neither. Now, of course, cotton candy is delicious, but I wonder what it would taste like after we put it into the liquid nitrogen. Do you think we should eat it? Awesome. How does it taste? Delicious. Awesome. All right. Give it up for Jennifer. Yeah. Did it give you brain freeze? No? Wow, okay. How about another trivia question? Okay. Which of the following foods is sometimes flash frozen using liquid nitrogen for its effect on how it tastes? Is it A, ice cream, B, sushi, C, pizza, or D, cheese? Which of these food items do we typically flash freeze with liquid nitrogen? What do you think? You think correct. It is ice cream. Let me get you a mix pen. Nice job. Awesome. Hey, why don't cryogenists like to go to parties? Because they always freeze up in social situations. All right. Once again, I'll ask everybody to remain seated, but if you would like to volunteer for this next activity, please do quietly raise your hand. I will ask those that participated already with the balloon to lower your hand. I want to get some new folks involved. So maybe let's see, maybe 1. Let's do 2. Let's do 3. And let's go with 4. Come on up. Yep. All right. So, we're going to play a little bit of a game here. Okay? Now, how many of you out there in the audience have ever been in love? Yeah, okay. Maybe you've played this game once or twice before where you're thinking about your crush and you've got a flower and you can start to pluck the petals off the flower and you might say, they love me now. They love me now. Right? Have you ever done this before? Okay, we're going to do something similar. And so I'm going to ask my 4 volunteers to pick one of the flowers from the bouquet of flowers each. Okay. Okay, that leaves me with the 5th and final flower. Okay, now we're going to go ahead and ask each person to put their flower right on the stage so that Jennifer can come on over and collect them. Awesome. Thank you guys. And you guys can actually go back to your seats. Thank you so much for helping me with this. The 5th and final flower, my flower, is going to determine how you all feel about my performance hosting this show. Do you love me or do you love me not? The way we're going to test this is we're going to freeze all the flowers and Chintan is going to smash them on the table. If they hold up, then you must love me. If they do not hold up to the test of love, then you must love me not. Are you ready? Yeah. 3, 2, 1. They love me not. Flower number 2. 3, 2, 1. They love me. Okay. All right. Here we go. 3, 2, 1. Oh, they love me not. Me too. Okay. Fingers crossed. 3, 2, 1. Okay, they love me. Interesting. And finally, my 5th and final flower. 3, 2, 1. They love me! All right! Whew. That's fantastic. Now, why did some flowers smash and some flowers did not smash? Well, as we mentioned before with the banana, flowers are living things that contain some water in their petals. So when we submerge them into the liquid nitrogen, the water quickly freezes into ice and makes the petal very brittle. So when we smash those flowers, their petals will break. Now, the flowers that did not break, those are fake flowers. How do you know my secret?
So those flowers are fake?
Okay. Sure, yeah. So the real flowers that we use, yes, they have some water in the petals, and then the water will, yes, the fake flowers will not break because there's water in their petals. How about this question? What is the name of the phenomena we observe when a superconductor is cooled with liquid nitrogen, causing it to expel magnetic fields? Is it A, the Doppler effect, B, the greenhouse effect, C, the Meissner effect, or D, the Mandela effect? Tell me, what do you think over there? D, the Mandela effect, is not correct. Sorry. I tricked you. I tricked you. What do we think? C, the Meissner effect, is correct. Very nice. Good job. One more quick joke. Okay. What do you call a cryogenicist with a six-pack?
Very happy.
The abdominal snowman. All right. We've got two more demonstrations to show you guys. This second to last one is actually one of the main things that comes close to what Brookhaven National Lab scientists and engineers are thinking about. Okay, so what we have is a kind of like a small little hockey puck shaped object. It is made out of a superconducting material, but right now it has not been submerged in liquid nitrogen. It is at room temperature. So when we place it up to a magnet, does it do anything fun? No. It's just going to kind of sit on top. So let's see what happens when we place the superconducting material into liquid nitrogen, cooling it past its critical temperature. Oh, we lost speed on the camera. Hang on, we gotta put a password in. Give us 1 second. Sorry about that. It should probably be okay. Okay, now our cooled superconducting material, we can take advantage of the Meissner effect and get our superconducting material to levitate above the magnet. Yeah. Not only that, but there's another kind of neat effect here. Besides just the Meissner effect, we can do what's called flux pinning. So we're going to kind of pin our superconductor to the magnet in a levitating way, but it won't just levitate. If we flip the entire thing around, it will also stay connected in some way to the magnetic field lines of the magnet. Pretty interesting, right? Now, some years ago, some scientists and engineers came up with a thoughtful idea based on what they were seeing with superconducting materials. They thought, hey, could we take advantage of this and create a magnetically levitating railway system? So, we've got one more superconducting material, and we're going to place it on top of a magnetic track that's on the sort of disc that you guys see on the screen here. Okay, we will pin the flux one more time. And give it a little push, and it will glide around the track. locked in place. What's neat about this is, unlike a regular train where the wheels sit on top of the rail, causing some friction between the two, this could be a train that floats right along the magnet, meaning it's frictionless. That allows the train to travel at much faster speeds, and those trains are sometimes referred to as bullet trains. So maybe you've heard about this. Give it up for the maglev. All right, folks, that's just about all the time we have to share with you. I want to say thank you so much for coming out and visiting Brookhaven National Lab today. Thanks so much for taking some time out of your afternoon to hang out with us. We've got one final thing to show you. It's a demonstration called the Magic Genie Lamp. What we're going to do is Jennifer and Chinton will take some cups of water and pour them directly into the remaining liquid nitrogen that we have in our styrofoam containers. That's going to release a whole bunch of what looks like steam coming over the top. I will ask, however, please everybody do not approach the stage. You can, after we do this, of course stand up and exit back up and get your Explorer stamps. You can take pictures if you'd like, but do not come towards the stage just as a safety rule. All right, let's count them down. 3, 2, 1. Thank you so much again.
Chỉ có cái cây thôi tẩm dần là xong thôi.